Hi, I'm Mark French, and this is the first in a series of video clips on how to use Mathcad. Mathcad, I think, is probably about the easiest way around to beat numbers out of a computer, and it's something I introduce to all my students. Generally, the reception's pretty good. Unfortunately, Mathcad sounds a lot like MATLAB, and they're two very, very different programs. I'm working with Mathcad here. Here's what the program looks like. It's basically like a scratch pad. You get to type things in, and the result looks kind of like it would if you were writing things down. Rather than talk about it, let me give you an example. Let's take a simple sine function, and let's go plot that. If I say insert, grab an XY plot, put in x, and f of x, there's a sine wave. And I can move this around, I can format it however I like. Perhaps I want to change the vertical plotting range here. That's easy to do. I'll hardwire those, and the ones in the x-axis I'll leave floating. Well, let's say that there's for some reason I want to plot the derivative of the sine function along with the sine function. And let's just do this. There it is. Okay. And if I want to put some grid lines up there, I can do this. And, well, maybe I didn't mean sine. Maybe I meant sine squared. There. There you go. There's the sine squared function in red, and its derivative in the blue dotted lines. Now, there's also a nice 3D plotting algorithm, or plotting function, I guess. Let me try something else here. Let me make up a function in x and y. Let's see, x squared times y squared, and let's make sure that doesn't overwhelm the solution. Let's divide by that. So there we go. There's a function of one independent variable here. This is two independent variables. So if I want to plot that, I'm going to plot it in 3 dimensions. So let's pick a surface plot, and there it is right there. Let me just put y in there and see what happens. Well, there you go. Yeah, it's not terribly easy to look at, so let's change a few things. Let's hide some lines and turn on the color map. There. That's pretty handy. Okay. Now, there's also a very nice symbolic. Get rid of these, clear my space out. Yep. There's also a nice symbolic capability built into Mathcad. So if I say sine x, I can take that variable toolbar, go down here, say differentiate. There's the derivative of sine x. Derivative of cosine should be negative sine, last I checked. And there it is. We can do things that way. We can do more complicated things like maybe partial fraction expansions. Let's imagine a simple ratio of polynomials here. Times, let's see, x, plus 4. I'll just make that up. Okay, I can go to variable and say convert to partial fraction. There's the partial fraction expansion. Now, if I change the expression up here, that doesn't change. But I can make it so that it does. It's called a live calculation. If I do this, there you go. Now, if I make a change on the original expression, it carries through. It recalculates automatically. And there we go. So there's how that works, which is also pretty handy. And I can even do things like series expansions. Let's say I want to do a series expansion on e to the x. Well, that's easy to do. Expand to series, and it'll ask me how many terms I want. So there you go. This is easy. This one's easy to look up. Mathcad really comes into its own when we start looking at expressions that are difficult to look up, that aren't tabulated anywhere. Sorry, wrong one. I meant. There we go. Let's try that now. There you go. There's what the series looks like for e to the x squared. A lot of programs have help features that are kind of afterthoughts, perhaps. Mathcad's help feature is really quite good. It's in my other window here. Let me bring it over. So there it is. There's a getting started part of the tutorial here that's really quite good, and in a few minutes you can be doing meaningful calculations. A really nice part is if you go to a function that looks pretty handy, we'll pick a root function, finding roots, there'll be what's called a quick sheet. A quick sheet is an example, and this is actually a Mathcad file. I can grab this out of the quick sheet, paste it into my own document, and now I have it. I can start using their example. So if I want to change any of this function up here, that will recalculate. If I said 0.84, I meant 0.804, it'll recalculate. Or 0.4, it'll recalculate. So there you go. This is just an introduction. In the later examples, later videos, I'm going to start looking at more specific features that my students use, and perhaps